last part of today is to find the nth term of a geometric sequence, meaning we're going to find a term in the future. Now if you have a geometric sequence, obviously you can keep following your pattern. So for instance, sequence A, we can take 5 times 2 get 10, 10 times 2 get 20, 20 times 2 get 40, and keep going until we find the 23rd term. But there is another way to get there, and it is to use the formula that the MCA sheet provides. Now, I'm going to teach you this way, that the MCA formula, or the way that the formula is used for an MCA type problem, because that's the formula that will be given to you. But in high school, and even in the book, you'll notice that it's going to be a little bit different. And there is one issue with this formula, which I will point out. So a couple pieces that you need to know here. This just stands for a function. And remember, for all functions, we always put a term in for x. So this just stands for the term, which means this is also the term. Okay? So whatever term we're looking for, that's what goes there. A, this is your first term. You'll probably remember that in the arithmetic sequence, we used something called the zero term. And then B, this stands for your common factor. Or basically, what are you multiplying by each time, or what are you dividing by each time? So if I plug that in here for A, here's what we'll notice. And I'm going to point out something that's wrong with this formula, okay, as you'll see. So my first term is 5, so I can say, okay, 5 times the common multiple. I'm doubling, so I'm multiplying everything by 2. And then I would put my term that I'm looking for up here, to the 23rd power. Alright, so I'm going to leave it like that for a second, but let's imagine we were looking for the second term. Let's say we were looking for 10, okay? We already know that the second term is 10, so this is 1, 2, 3, and 4. Now if I follow this same formula rule, I would say, okay, my first term is 5. And my common multiple is 2, because I'm doubling each time, and I'm looking for the second term. Okay, we run into a problem though. Because if I take 2 to the second power, I get 4. And 5 times 4 equals 20, which is the third term. I'm not looking for the third term, I'm looking for the second term. So what we have to add to this formula is this little piece right here. And this is why I don't necessarily agree with this formula, but that's what we're going to have to use, because it's what the MCAs gives us, is we're going to put a -1 here. And what ends up happening then is, if I use the same example I just showed you, shouldn't have erased it, 5 times 2 to the second term minus 1, well, this is 5 times 2 to the, and 2 minus 1 is 1. Well, 2 to the first power is 2, and 2 times 5 is 10. So that's why we do that. We got to add the little -1 in there. So what we would do is figure out, we'd have to use a calculator. We're going to get a very large number. We would take 5 times 2 to the 22nd power. So I can do that. 5 to the 22nd power, and then take that times 5. So you remember, you always want to do this piece first, and then, so 2 to the 22nd power times 5. If I open up my calculator right now, my video will stop, so I'm going to leave it just like that. We'll talk about it tomorrow on how to go further, and I'll just help you set these ones up here, and we'll get the answers. So here, this is a geometric sequence. We're multiplying by -2 each time. Okay, so I'm going to take my first term times my common multiple, -2, and again, 23 minus 1, which is going to turn into 22. Okay. Now we're going to expect to get a negative, because -2 to the 22nd power is going to come out to a positive number, and then times -3 will give me a negative number. Alright, and lastly, we'll notice here that we're dividing by 5 each time. 100 divided by 5, 20 divided by 5, 4 divided by 5. So I'm going to say 1/5 is my common multiple or factor. And my first term is 100 times 1/5, and 1/5 then will be to the 23 minus 1 power, or the 22nd, and then we'll get an answer from there too. Alright, so we could expect a very small decimal for that one. Alright, but anyway, like I said, we'll go over the rest of that tomorrow, and that's how we set these up to find these future terms. Alright.